this session, let's understand about binary search. Binary search is a fast search algorithm. Why it is known as fast search algorithm will be understood at the end of this session. So binary search algorithm works on the principle of divide and conquer. That means the array that is being searched will be divided into two different parts. And that is why it is known as binary search. Bi means two. So the array will be divided into two different parts. And one point to be noted is that the array will be in a sorted form to apply binary search algorithm. That means all the elements in the array should be in ascending or descending order. If the array is not in sorted form, then it is to be sorted first and then apply the binary search algorithm. So let us understand how this algorithm works. Binary search looks for a particular item by comparing the middlemost item of the array. And if the middlemost item is the searching element itself, then a match occurs and the index of the item will be returned. And if the middle item is greater than the item, then the item is searched in the subarray to the left of the middle item. That is, the array is always in a sorted form. That means if the middle item is greater than the item that we are searching for, then it is obvious that the element that we are looking for will be towards the left side of that array. Then searching is to be performed only in that particular portion. Otherwise, the item is searched for in the subarray to the right of the middle term. That is, if the middle term is less than the item that we are searching for, then clearly the element that we are searching for lies towards the right side of the middle term. Then searching is to be performed only in that particular part. So this is how binary search algorithm works. And this process will be continued on the subarray until the size of the subarray reduces to 0 or a match is found. So this is why the algorithm is known as divide and conquer. So let us understand this with the help of an example. So here you can see an array. So here you are taking an array that consists of 10 elements starting from the index 0 to 9. That is total. Here we have 10 different elements, and you can see that all the elements in this array are arranged in ascending order. That is, it is a sorted array. Now let us suppose that we are searching for an element 31. So 31 is to be searched and the position of 31 is to be returned as the output. So in order to perform binary search, first of all, we have to calculate the middle portion, middle element. We have to find what is the middle element. In order to find the middle element in the array, this equation can be used. That is, mid is equal to low plus high by 2. Low, mid and high represents the indices of this array. So initially, low will be the lowermost index and high will be the last index value. Here, according to this example, low will be equal to 0 and high will be equal to 9. So by applying this formula, we get the mid value, that is 0 plus 9 by 2 will give 4.5. The actual value will be 4.5, but we are here taking the floor function, that is the element that is lower to the lowermost integer is taken, that is 4. So here mid value will be 4. This is because we are taking only the integer values, because always index will be represented using an integer value. That is why it is rounded off to the floor value. So here you get 4 as the middle value. Now the element at the fourth position is compared with the element that is to be searched. So here we are searching for 31 and the element belonging to the fourth position is 27. So 27 is compared with 31, that is whether 27 is equal to 31 or not. we can see that 21 is not equal to 31. Therefore, a match is not found. Then the process is to be repeated again. Now, but we don't have to repeat this entire procedure, comparison process towards to the entire array. Instead, we can only compare elements towards one side of the array. So, what portion of the array is to be compared next? By checking the middle value, we can take a decision. That is, 27 is the middle element here, and we are searching for the element 31. So, it is clear that 31 is greater than 27. That is, middle value is less than the element that we are searching for. That means the element will be lying towards the right side of this array. Next comparisons are to be made only towards this portion of the array, starting from the next element onwards. Okay, we have to only check the elements belonging to the right side of the middle term. So, in order to change the index values, now we have to change the value of low to mid plus 1. That is, the low and high values are to be modified in some cases. Here, the low values to be modified because the elements are to be compared from the next position onwards. That is why we have to choose or change the value of low here. So, the low value will become 5 in the next iteration and high value remains the same. So, let us proceed. Now, we will start from 5 to 9. Okay, again we have to split this subarray into two different parts, starting from the low as 5 and high as 9. Again, you have to find the middle value of this particular array, that is this subarray. We have to perform the same procedure. Now, we can apply the equation, that is low has changed to mid plus 1 and middle value can be calculated by using the same formula as before, that is low plus high by 2. Now, low is, so in the previous case we have taken mid as 4. Now, low will become mid plus 1. That is, here low will be 5 and high will remain the same. So, applying this formula, you get 5 plus 9 by 2. That is 14 by 2. This will give 7 as the answer. So, now the mid value is 7. So, the middle element will be 7 here. Again, we have to compare the element at the position number 7 with the element to be searched, that is 31. So, a comparison is made, that is whether 35 is equal to 31 or not. Now, we can see that it is not matching with the value, that is 35 is not equal to 31. Therefore, we have not found the element. Now, you can understand that 35, that is the middle value, is greater than the value that is being searched. Now, we have to apply the searching only towards the left side of this middle value, that is only these elements are to be compared in the next iteration. So, in order to compare these elements in the subarray, we have to adjust the value of high value. High is to be reduced by 1 from the mid position. That is, mid value here is 7 and next only we have to compare only these two elements. Therefore, mid value can be reduced by 1 and made as the high value. That is, high will become mid minus 1. High becomes mid minus 1. That is, mid was 7 and 7 minus 1 will be 6 here. Therefore, high will be 6 now. And again, we have to find the middle value by using the previous formula, that is low plus high by 2. By applying this formula, you get low plus high. Low is 5 itself. High will be 6 and this divided by 2. 11 by 2. 11 by 2 is equal to 5.5, but we are taking the floor function, therefore the mid value will be equal to 5. Therefore 5 will be the value of mid. Now the element at the position number 5 is compared with the element that is being searched, that is element at position number 5 here is 31 and we are searching for element 31. Hence a match is found. Therefore the position of this element will be returned as the result, that is element 31 lies in the position number 5. That is the final result, and we will complete the process. So this algorithm is applied several number of times until a match is found, but the total number of comparisons here is reduced as compared to linear search. What we have done in linear search is we are comparing all the elements starting from the initial position of the array to the final position of the array. All the elements are compared with the element to be searched, but here the number of comparisons are reduced to up to an extent. Therefore it is known as the fast search algorithm as compared to linear search. Now let us see the algorithm for binary search. So this operates on array A, and the lower bound is the lower index of the array, upper bound is the upper index of the array, and val is the value that is being searched. So initially set the value of low with the lower bound. So the lower bound will be always at the initial case, or lower bound will be equal to 0, and upper bound will be the elements present in the array minus 1. That is, high will be set as upper bound, and POS is the position of the array elements. Initially it is set as minus 1, and the process is to be repeated until we find a match or the size of the subarray becomes 0. So repeat steps 3 and 4 while low less than or equal to high. And the next step is set mid is equal to low plus high by 2. So we are applying the formula for finding the middle value, middle position, then comparing the elements with the mid value, and if a match is found, if A of mid is equal to value, that is value represents the element that is being searched and A of mid represents the value at the mid position, and if it matches, then position value will be set as mid, and this position is returned and the program will be exited. Otherwise, that is, if A of mid is greater than the value, A of mid is greater than the value means we have to search the element towards the left side of the array. That is, the element that is being searched is less than the middle value. Therefore, always this element will be belonging to the left side of the array. So, the high value is to be changed. That is, high is to be set as mid minus 1, and this process is to be continued again. Otherwise, that is, if A of mid is less than value, then low value is to be set as mid plus 1. That is, the array that is to be searched is towards the right side of the middle. So this process will be continued until a match is found. So this loop repeats again and again, and whenever we find some match, the program can be exited. And one more situation can occur, that is, the element that we are searching for does not belong to the array. In that case, after completing this loop, then in step number 5, if position is equal to minus 1, that is, if we have searched for an element and we have not found that element in any of these positions, then the position remains minus 1. And then we can decide that the value is not present in the array and the program will be exited. If you want to understand this more clearly, you can take an example here. Let the array be 2, 3, 5. We'll take a smaller array. Now, we have to find the middle position. So the indices of this array will be 0, 1 and 2. So initially low will be 0 and high will be 2. So we have to find the middle value. Middle value will be 2 plus 0 by 2, that is equal to 1. So mid value will be equal to 1. And if we are searching for the element 2, let us take, we are searching for the element 2. Now mid value is not matching with the element that is being searched. That is, middle position element is 3. 3 is compared with 2 and it does not match. Therefore, we have to repeat the procedure. Now we know that since it is a sorted array, we know that middle value is greater than the value that is being searched. That means the value lies towards the left side of the array. So only this side is to be searched in the next iteration. Now we have to change the high value. High value will be reduced by 1 of the mid. That is, mid minus 1 will become the high value next. That is, high will be 0 and low will also be 0. Then again mid value will be calculated. That is, low plus high by 2. That will return 0 as the result. Then that is, mid becomes 0. Now then the element at the 0th position will be compared with the element that is being searched. That is, 0th element will be compared with element that is being searched. Both are same. So we can return the value of the index as the result. Hence the position is 0 and the position 0 will be returned as the result and the program exits. And we can take the other situation, that is, we are searching for an element 4. If we are searching for an element 4 in this same array, we know that this element is not in this list. But we have to proceed as the steps shown here. So initially we will find the position of the mid value. That is, we will find the mid value that will give us 1. And 1 does not, the position element at the position 1 does not matches with the element that is being searched. That is, 3 does not equal to 4. Then we have to proceed towards the right side of the array, because we are searching for an element 4 and the element at the mid position is 3. That is, this element is less than the element that is being searched. Therefore, there is a chance that the element 4 may lie towards the right side of the array. So now the high value remains the same as before. That is, high value will be 2 in this case and low value is to be changed. Low value will become mid plus 1. Mid value here was 1 and now the mid value will become plus 1, that is 1 plus 1, 2. Mid value becomes 2. So both the values of high and low are 2. 2 plus 1, 2 plus, now again if we are calculating the value of mid, we will get 2 plus 2 by 2, that is 4 by 2, 2 itself. So the element at the position 2 will be compared with element 4, that is 5 will be compared with 4. It doesn't match and therefore the value does not match and we can say that the element is not present in the array. This is how this algorithm works. Now coming to the time complexity of this algorithm. In worst case, the algorithm has a time complexity as of big O of log n. And the best case complexity is that big O of 1. Average case complexity is also similar to worst case, that is big O of log n. This condition is present here because we have divided the array into different subparts and the elements in the subarray is being searched. That is why that many number of comparisons will be present in order to find a match. So that is why in worst case, the time complexity of this binary search algorithm is given as big O of log n. And in the best case, the element will be found at the first step itself. If you want to find the element in the first step itself, then the element should be residing at the middle position. That is, whenever we divide the array into two, the middle element itself will be the searching element. In that case, it is known as the best case of binary search, and we have to make only one comparison. Therefore, the time complexity will be big O of 1. So these are the time complexities of binary search algorithm. So that's all about binary search algorithm. Thank you.